So let's think about this question. We have, in this question, we have probability of 0.9 of B minus or better if a student has done all assignments. So this is condition. Finishing all assignments is the condition. On the other hand, if the condition is missing some assignments, then the probability reduces to 0.2. So let me write it this way. Say B means event B denotes event B minus or better. And I will denote A for the event that finish all assignment. Okay, so if you do all assignments, then what is the probability of getting B minus or better? All right, the information we have here first paragraph tells us probability of B minus or better given doing all assignment is 90%, right? If the condition is, so if you finish all the assignments, then this probability is 90%. On the other hand, if you do not finish all the assignments, so complement, I'm using complement notation, which means A not A does not happen. So if you do not finish all assignments, the probability of B minus or better is only 0.2, 20%. And then I expect 70% of students do all the assignments. That means it is unconditional probability among all the students finishing all assignments is 70%. Given these information, I'd like to calculate the probability that a student gets B minus or better. So this is unconditional probability. Out of all the students who take this course, how many of them can get B minus or better? So I will use the tree method again. 1,000 students. Imagine there are 1,000 students who are taking my class, right? So then I will divide them into those who do all the assignments and those who miss some assignments, right? So given using the unconditional probability first, 70% finish all the assignments, but the other 30% do not finish their, so miss some assignments, okay? And then I am going to split the first group into those who get B minus or better, and let me simply write it as B or better, and say C plus or lower. So out of 700 students who finished all the assignments, 90% will get B minus or better because they satisfy this condition, and this is the probability. So 90% of 700 is like 90% and 10%. 90% of 700 is 630. And 10% of 700 is 70. And now look at the other group. It's 300 people, like students, who do not finish all the assignments. And then 20% get B or better, and the other 80% receive C or lower. Okay, so 20% of 300 is 60 students. 80% of 300 is 240 students. So starting from 1,000, imaginary 1,000 students, I classify them using the information, the probability given in the question. I classify them into 4 groups. And then we are interested in this event, B minus or better in the end. And we will have this group and this group who get B minus or better at the end. So out of that means out of total 1,000 students, because we are considering unconditional probability, 630 plus 60 is the number of students who get B minus or better.